like this is I would again convert it into the radical form like how you would actually see it. So we're dealing with fourth root of 81 x to the 6th y to the 8th. And then look to simplify what you have. So when you're looking at this, you have 81, which you can see is a perfect square. It is 9 squared, but 9 is also a perfect square. So you could think of that as 3 squared, or 3 to the 4th. So when you're simplifying this, if you think of 81 as being 3 to the 4th, it makes it a little bit easier to see when you're reducing or simplifying. You're looking to remove any factors that have a power of 4. So here we have 3 to the 4th. When you take the 4th root of that, you remove or you take out just the base 3, and you're left with nothing inside the radical. So we'll leave the radical alone. As you progress through these, it's very systematic. You just work with different exponential bases. So we worked with the numerical base of 3 first. Now we move in and work with the x's. So this exponent x to the 6th, when you take the 4th root of that, you're looking to remove groups of 4 from its power. So how many groups of 4 can you remove from the x's? From 6 x's, you can remove one group of 4, so that comes out as x to the 1st. And how many x's are going to be left inside our radical when we remove one group of 4 from 6? 2. Okay, and then move to the y's. How many groups of 4 can we remove from the y's? 2 groups of 4 is 8, which leaves how many y's inside the radical? None. We took out all the y's. Okay, so here is your simplified form, 3x y squared. Now, if you entered 4th root of x squared, it's not going to give you the correct answer. And the reason for that is one of the other properties to represent simplified radicals is the index and the powers cannot have any common factors. Okay, so 4 and 2 have a common factor. So you have to simplify these. The easiest way to simplify them is to convert them back into their rational power form. So x to the power of 2 over our index of 4, because now it's easy to see. What does this reduce to? X to the what? 1/2. And then we can translate this back into the radical form. Our index is 2, our base is x, our power is 1, and when we write our answer, we don't write the index of 2, it's an unwritten index. We don't need to write powers of 1, so we get the square root of x to fill out our solution for that one. How to use the calculator too. Okay, because, like I said, it's possible to use the calculator. The difficulty comes in interpreting what the calculator displays. Because if I was to write the 4th root here, what I might do is take this entire quantity, 81 to the power of, or I'm sorry, write the entire value inside the radical. So 81 x to the 6th times y to the 8th. Close that off and take it all to the power of 1 over 4. Again, that's just converting it into rational power form. When I hit enter on this, you notice that the display shows the following. Okay, so if you don't understand how it's possible to get from this form into this answer, then using your calculator for this is going to be more work or more trouble than it's going to be help. Okay. As far as how you would convert it, you see that there's a 3. The absolute value of x doesn't really concern you guys. We're not going to emphasize when it is and isn't an absolute value in this class. So when you look at this, you have x to the power of 3/2. Well, 3/2 is 1 and 1/2, right? So that brings 1x out, and it leaves 1x, or x to the 1/2 still remaining. Well, x to the 1/2 is the square root of x when you convert it into radical form. And you have y squared. Okay, and so you can, or you should be able to see that you can convert it into that form. But if there's any problems on that, it's going to be difficult for you to interpret what the calculator is showing.